Okay, so how do I find the component forms of those vectors?
Wouldn't you have to do the slope?
Yeah, you can do that. That's the right idea. You need to find the two sides of the triangle, right?
Okay, so you just have to go count the little hash marks.
Yeah, you could do that too. So it looks like I go 3 to the right.
3, and then up you go 1, 2, 3,
4.
4 up.
Now, what you're trying to do is you're acting like this point right here is the origin. If you just kind of extended this over and put that vector right there, it's the same thing. So your component form is 3 to the right and 4 up. Now, if you don't have a picture and you just have the terminal and the initial point, you know that it's terminal minus initial.
And that is to find
the sides.
All right.
So, you got your 5, 3.
Y minus the y2 minus y1, x2 minus x1 stuff.
Yeah, it's just that you're not dividing them in. You're not putting the y's over the x's. You're just subtracting these two. And that goes here.
A way to remember
subtracting these two, put it here.
Another way to remember it is Texas Instruments.
Texas Instruments, TI. That's right. All right. Now, let's clear that out and move this up. Okay, so these are just basic definitions. Magnitude. Okay, it's the magnitude of a vector is just the length of the hypotenuse, which is Pythagorean theorem. All right, so now in this particular example, we talked about so this would be review. You've got -3, 4. Whoops. 1, 2, 3, 1, 2, 3, 4. So we got our first point, -3, 4, and -5 and 2. So there's my vector right there. What are the components of that vector?
Now Q is Q the terminal point?
Yes, we can see there that Q is the terminal point.
All right, and then what? All right, so then we would have to go put the initial under it, or else we would get a number that would probably be way off. So anyway, -5 minus a -3.
So -5 minus a -3 would be the same thing as -5 plus 3,
which is -2.
Okay.
And then 2 minus 4 is -2.
So we have the component form -2, -2,
Oh.
which makes sense because it's 2 to the left and 2 down. But they want the magnitude of that vector. That's what those little absolute value bars look like.
But it doesn't mean we have to actually make it 2, 2.
Oh, no, not at all.
All right, that's what always I find misleading. That just always threw me off.
Well, those are the kinds of questions I want you to ask in class and say, okay, what does that notation mean again? Because
I just can't think of a way to word it in which everybody would understand it.
Well, just talk to me and don't worry about them. I try to figure out what kids are asking all the time so that I can understand the question and the struggle and help them fix the problem.
Because, I often looked at it this way, that you being a teacher, it's almost like you are, every day in class, you are the attorney. And then all of us are the Supreme Court justices.
Really?
Because you are presenting
an argument
to us.
Yeah.
And we then will then butt in, just like we do in Supreme Court arguments, and ask questions about it.
Yep, that's fine. I need to know what the magnitude of this is.
Well,
it's the length of the vector.
That would be 4 plus 4.
Ah, yes, 4 plus
8.
4.
Square root of 8, I believe, would be too radical.
Yeah.
I believe,
Yeah,
yes.
if you simplify it. That's not the most critical thing in the whole wide world, but that is true.
I mean, it's, yeah.
So, alright, so adding vectors is easy. You just add the x's and you add the y's.
Naturally.
And so the picture of that looks like this. This is very typical of the problems that we dealt with the airplane and the wind speed and how they combine together. And that's whether or not the wind is going with the plane or the wind is fighting against the plane. You're still adding two vectors together. So, this is just a picture of, vectors, and if you double them, you increase the length, but you keep the same direction. The only thing that would cause the direction to change would be a negative multiplier.
Right, because then it's going in the
opposite direction.
Negative direction.
So I don't think you probably need to spend time reviewing adding. You're probably pretty good at that. Making unit vectors.
And that is, in that case, the vertical lines are an absolute value, or is it a magnitude thing again?
Okay, so if you look at the definition that's up above, it says, in order to change something to a unit vector, you have to find the magnitude of it and do what with it? What do you do with the magnitude to the vector?
What do you do with the magnitude?
It says right here. It says right here that
divide it.
Correct. I'm supposed to take the vector and divide by the magnitude. So take the vector and divide by the magnitude. All right. So what is the magnitude of negative 3, 2?
Okay. That would be 6 plus...
No, wait a second.
No, it's 9.
Ah, yes. 3 squared is 9 plus...
It's 9 plus 4.
So we have the square root of 13, right?
Yes, and that just states how it is.
Okay, now I told you that one way to write that, so if I have the vector, and you can see it over here, is to put 1 over the square root of 13 on the outside. That's one acceptable answer for the unit vector.
All right.
Okay, now, Math Excel didn't like that. They wanted it pushed in. So Math Excel was looking for something like this.
Good morning. Just a reminder, if you are giving the sophomore I-step today, please stop by room 303 and pick up your materials before first period.
Okay, we'll do that. Anyway, so that's what Math Excel was expecting. That would also be acceptable to me.
Alright, so basically when you write the answer for a unit vector, you just do your vector, but then just write the magnitude under both numbers.
Yeah, because you're dividing, just like you said. Yes. We're dividing. Okay?
Yes.
So this is kind of I think this is kind of ridiculous, but the i's and the j's, it's just another way to write it. So instead of writing vector 2 3, another way to write that is 2i plus 3j. It's called a linear combination. Now, the reason I don't like it is because in coming sections, you know that we get into the complex numbers, and then we start doing the polar form.
Imaginary.
Right, and so now we have a plus bi, and now we're throwing in i's, and that's not what they're talking about here. This is just notation which refers to real vectors, 2 to the right and 3 up. And so because we don't use this notation very much, I'm not even going to put it on the test. I'm not going to ask a linear combination
Yeah,
question.
that always threw me off.
Well, we don't do much with it, so I'm not going to spend a bunch of time. I'm not going to test over that. I had it on a quiz, and I felt like it was pretty much a waste of time. Now, I hope this looks, now that you've done stuff with in the polar section where we had x equals r cosine theta and y equals r sine theta, I hope this looks familiar to you.
Oh yeah.
Because
it's just the
if you want, the magnitude and direction can tell me the components. If I know the magnitude and the direction, you give me any vector, all right? Or so let's say I say the magnitude of vector v is 3, all right, and the direction theta is 205 degrees. Okay? I have enough information there to come up with the components. Because this is, you're basically looking at something that's in, you're down here in this quadrant, looking at this vector. I'm looking for the x and the y. And I know that the magnitude of that is 3. This angle that I've drawn here is 205 degrees. So, what can I do to find, according to what you see right there?
Well, you could do the we know the magnitude is 3.
Okay. So what am I going to do with the 3?
Well, you need to find the other 2 legs.
Well, look at what the formula tells me to do. If you want to find the x leg,
you just have to do the cosine of 205, right?
Yeah. Times what?
Theta. Well, not 205.
Well, no. Cosine 205 is
205.
But what do I do
theta.
with it? What am I saying that I'm going to do with it? What does it say to do with the cosine of 205? Multiply it times what?
By the 3, the magnitude.
The magnitude, yes. So 3 cosine 205 is going to spit out the x component, and that's not going to be a nice number. I don't have my calculator in front of me, but it's not going to be, because 205 is based on a 25-degree angle inside the triangle. That was not one of the nice ones on the unit circle.
Right.
So how do I find the y component?
Same thing. You do. You just use the same numbers, except you move the s over to the left 2 places and input an I and an n.
Okay, so sine 205, but what do I do with the sine 205?
Maybe you have to go put a 3 right before the s.
You got to multiply it by 3. This was exactly the same type of question that you had on the first part of your quiz, your last quiz. I gave you a coordinate in polar, and I asked you to come up with the rectangular. So it's absolutely no different. It was r cosine theta, r sine theta. So if you get this for polar, you can do this for vectors too.
Right. I mean, it's just because we did this before spring break.
Okay. I'm pretty sure we've done right triangles for a long time.
Lesson, though, we did a while back.
Okay, so how do I find the components of this vector?
Well, first of all, you need to draw 2 legs onto that.
Okay.
And that 6 represents the magnitude. So what you would need to do is you need to do 6 cosine 115 and then 6 sine 115.
What mode should your calculator be in if you're typing this on a calculator?
Degree.
Oh, good. Nice. Yeah, make sure you have it in the right mode, otherwise you'd get the wrong decimal approximations.
That would be bad.
Are you good on time, or do you need to leave?
I need to leave.
Okay. All right. Come back tomorrow.
All right.